This chart shows the baseline scale of the Axios package, a JavaScript library that records over 100 million weekly downloads, making it nearly ubiquitous across web applications. The malicious versions of Axios were live on the NPM registry for a tight 3-hour window. Despite this short exposure time, active telemetry confirmed the first downstream host infections occurred almost immediately. It took exactly 90 seconds from the moment of publication for the compromise to reach developer workstations, cloud instances, and continuous integration pipelines. Automated modern software delivery meant the infection spread globally before human defenders could register the threat. Structurally, Axios is a promise-based HTTP client for JavaScript. It functions primarily as a transitive dependency, automatically installed by countless enterprise applications without direct developer intervention. In this incident, threat actors compromised an authorized maintainer's NPM account, injecting malicious code to achieve cross-platform remote code execution. We will deconstruct the architecture of this attack, tracing the initial ecosystem bypass to the deployment of environment-aware malware. The attack weaponized the architecture of trust inherent in modern software development. The initial vector was a direct compromise of an authorized Axios maintainer's registry account. The attacker bypassed standard GitHub Actions controls, opting for a direct entry route into the NPM registry. They established access using compromised recovery codes to override two-factor authentication gates. Once inside, they generated a long-lived access token, locking in persistent access to the repository. Robust pipeline security fails if the underlying identity architecture and credential management are breached. With access secured, the attacker published specific tainted versions of the library, Axios versions 1.14.1 and 0.30.4. This dependency tree shows those releases injected with a hard-coded requirement for a phantom dependency named plain crypto.js version 4.2.1. This typo squatting strategy is designed to trick anyone auditing the code into thinking it was the legitimate, widely used crypto.js package. This newly created plain crypto.js package contained absolutely no functional code for the Axios library. Its sole function was acting as a delivery mechanism, executing a malicious post-install script upon resolution. The transitive trust model allows attackers to hide a dropper deep in the dependency tree, forcing automatic execution simply by running a standard package update. The malicious post-install hook triggers the execution of a specific script named setup.js. To hide the payload's true syntax from static analysis, the script initially relies on reverse base 64 and XOR decryption techniques. Once running, the script generates a post request designed to mimic normal, benign NPM repository traffic. This request silently passes the victim's operating system details back to the attacker's infrastructure. The command and control server reads the operating system data and toggles its response, serving a distinct payload variant based on whether the target is Windows, Linux, or macOS. The exact domain handling this traffic is sfrclack.com, operating on port 8000. The dropper acts as an automated scout, delivering an environment-optimized weapon while hiding communications in plain sight. Looking at the Windows process execution tree, the payload begins by writing and tucking away a hidden Visual Basic script. The script then calls wt.exe, the native Windows terminal, which in turn executes PowerShell. Utilizing wt.exe mimics natural Windows 11 execution patterns, allowing the process to evade endpoint detection and response heuristic triggers. PowerShell triggers cmd.exe to execute a curl command, fetching the next stage of the payload from the command and control server. Finally, the Windows Remote Access Trojan establishes persistence by writing to the current user registry hive. The Windows execution chain leverages the operating system's own modern administrative tools against it, transforming standard functionality into an evasive execution sequence. The Linux and macOS execution branches utilize a Python-based remote access Trojan. These Python payloads contain no persistence mechanisms. There are no cron jobs and no bashrc hooking. These payloads are optimized specifically for continuous integration and deployment pipelines, which are inherently temporary, ephemeral environments. Their sole operational goal is rapid execution, designed to aggressively scrape API keys and secrets before the automated pipeline tears itself down. In automated cloud environments, malware only needs to survive the few seconds required to extract credentials. This matrix outlines the primary indicators of compromise teams must track: Axios versions 1.14.1 and 0.30.4, the plain crypto.js dependency, and the sfrclak.com domain. The malicious post requests included campaign ID 62033H. A forensic reversal breaks this string into 330 and 2026. This decodes to a future date, acting as peculiar attacker telemetry or a predefined campaign marker. These forensic traces reflect the calculated, programmatic nature of modern supply chain threat actors. Immediate mitigation requires an aggressive audit of all environment configurations. Teams must check exact dependency resolutions mapped inside lock files to identify the hidden malicious package. Because this infection targeted automated infrastructure, all exposed CI/CD secrets must be assumed compromised and rotated immediately. The compromise targeted the transitive trust architecture itself, rather than a zero-day vulnerability in the codebase. In a world of instantaneous dependency resolution, an ecosystem vulnerability can compromise global infrastructure faster than human defenders can sound the alarm.